back. In this lesson, I want to introduce cloud computing. It's a phrase that you've most likely heard, and it's a term you probably think you understand pretty well. Cloud computing is overused, but unlike most technical jargon, cloud computing actually has a formal definition, a set of 5 characteristics that a system needs to have to be considered cloud. And that's what I want to talk about over the next few minutes in this lesson. Understanding what makes a platform cloud can help you understand what makes cloud special and help you design cloud solutions. So let's jump in and get started. Now, because the term cloud is overused, if you ask 10 people what the term means, you'll likely get 10 different answers. What's scary is that if those 10 individuals are technical people who work with cloud day to day, often some of those answers will be wrong. Because unlike you, these people haven't taken the time to fully understand the fundamentals of cloud computing. To avoid ambiguity, I take my definition of cloud from a document created by NIST. And NIST are the National Institute of Standards and Technology, which is part of the US Department of Commerce. NIST creates standards documents, and one such document is named Special Publication 800-145, which I've linked in the lesson text. And I've also included it in the lesson folder on the course GitHub repository. The document defines the term cloud. It defines 5 things, 5 essential characteristics which a system needs to meet in order to be cloud. So AWS, Azure and Google Cloud, they all need to meet all 5 of these characteristics at a minimum. They might offer more, but these 5 are essential. Now, some of these characteristics are logical, and some of them may surprise you. The NIST document has a definition for each of the criteria, and I've attempted to simplify them further down to their core essence, and where required, updated them a little. So let's take a look. Essential characteristic number 1 is on-demand self-service, and the NIST document defines this as a consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. Now, I've simplified this as you can provision capabilities as needed without requiring human interaction. And I've highlighted the important part, without requiring human interaction. In this context, capabilities just means features or products, so this can include virtual machines, storage, databases, or networking. With AWS, Azure, and Google, you can log into a web interface or open a command line or use APIs in your own self-written applications and provision resources inside your cloud accounts. It's self-service. You don't need to liaise with a support or a provisioning team. And it's on demand. You don't need to inform the vendor days, weeks, or months in advance. If you can do this, if you can provision any resource whenever you want without involving humans and without delay, it meets this criteria. If not, it's probably not cloud. Now, this characteristic is pretty clear. It's usually obvious if a system meets it or not. Let's move on to number 2, which is broad network access. Now, NIST defines this in a fairly wordy way as capabilities are available over the network and accessed through standard mechanisms that promote use by heterogeneous thin or thick client platforms, and it gives examples of mobile phones, tablets, laptops, and workstations. Now, the NIST wording is somewhat dated. My idea of a simplified version is that capabilities are available over the network and accessed through standard mechanisms. And the key points that I've highlighted are network and standard mechanisms. With AWS, Azure, and Google, you can access services over a standard network using standard means, so HTTP, HTTPS, SSH, remote desktop, or maybe using a VPN. If you need to visit a data center or go to a vendor's facility to interact with your data and/or systems, it's probably not cloud. If you need a private network link to access your environment, it's probably not cloud. Now, this characteristic feels dated because at this point, we almost take this for granted as an industry. Everything is available over the internet, but this hasn't always been the case. So again, in order to be considered cloud, whatever system you're looking into needs to meet this characteristic. So let's move on. Number 3 is resource pooling, and the NIST document has a very long definition for this one. The NIST definition is that the provider's computing resources are pooled to serve multiple consumers using a multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to customer demand. And it goes on to say that there is a sense of location independence in that the customer generally has no control or knowledge over the exact location of the provided resources, but may be able to specify location at a higher level of abstraction. Examples of resources in this context include storage, processing, memory, and network bandwidth. Now again, I've tried to simplify this, and I've simplified it into 2 points. First, there is a sense of location independence, no control or knowledge over the exact location of resources. And secondly, that resources are pooled to serve multiple consumers using a multi-tenant model. Now, this characteristic is about abstraction and economies of scale. With AWS, you instruct the provider to deploy a virtual machine in a certain region, but they're free to use whatever data center they want. They're free to use whatever hardware vendor they want. This means the risks of that process are with the vendor, and this seems like a good thing, and it actually is. But historically, it was the cause of initial resistance to using cloud computing because IT managers were used to thinking of servers and hardware as their assets, things of value to the business, instead of things which host the applications and services which are the actual things of value to the business. So we've moved away from thinking of hardware as value to thinking of applications and data and services as the things of value that a business offers. Now, the second part defines how cloud vendors pool the needs of their customers together. Instead of businesses buying for only their own needs, so 10 servers for company X and 10 servers for company Y, the cloud vendor might procure 10,000 servers for use for part of their customer base. Larger scale means better economies of scale. It means that the cloud vendor can maintain a larger buffer for growth. A 10% growth buffer on 10,000 servers is 1,000 servers. If every company individually maintained their own buffer, it would be 10% of 10 servers, which is only 1 server. So if a company wanted to grow more than 10% individually, it would hit a capacity wall. But if all these companies are running inside a cloud vendor, which allocates 10% of this pooled platform, then there's a lot more room for growth. Pooling allows for easier scaling whenever a customer needs it. Now, this is a pretty abstract one to understand, but when communicating or using a platform such as AWS, Azure, or Google, you never really see mention of your servers or your storage. You allocate it from a pool and return it to that pool when it's no longer required. And behind the scenes, the vendor is managing that capacity. What cloud does is it has isolation between customers. So your data is only visible to you. So even though the cloud vendor is using pooling, and even though you and another business are probably sharing physical hardware, you would never know each other existed. And that's one of the benefits of pooling. But on to characteristic number 4, which is rapid elasticity. The NIST document defines this as capabilities can be elastically provisioned and released, in some cases automatically, to scale rapidly outward and inward commensurate with demand. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be appropriated in any quantity at any time. Now, I simplify this again into 2 points. First, capabilities can be elastically provisioned and released to scale rapidly outward and inward with demand. And in this case, capabilities are just resources. And second, to the consumer, the capabilities available for provisioning often appear to be unlimited. Now, when most people think about scaling in terms of IT systems, they see a system increasing in size based on organic growth. Elasticity is just an evolution of that. A system can start off small, and when system load increases, the system size increases. But, crucially, with elasticity, when system load decreases, the system can reduce in size. It means that the costs of a system increase as demand increases and the system scales, and decrease as demand drops. Rapid elasticity is this process but automated, so the scaling can occur rapidly in real time with no human interaction. Cloud vendors need to offer products and features which monitor load and allow automated provisioning and termination as load increases and decreases. Now, most businesses won't care about increased system costs if, for example, during sale periods their profits increase. And because the system scales along with that increased load and increased profits, the customers are kept happy. Elasticity means that you don't have to, and indeed can't, over-provision, because over-provisioning wastes money. It also means that you can't under-provision and experience performance issues for your customers. It's how a company like Amazon.com or Netflix can easily handle holiday sales or handle the load generated when the latest episode of Game of Thrones is released. The second part is related to that. A cloud environment shouldn't let you see capacity limits. If you need 100 virtual machines or 1,000, you should be able to get access to them immediately when required. In the background, the provider is handling the capacity in a pooled way, but from your perspective, you should never really see any capacity limitations. Now, this is, in my opinion, the most important benefit of cloud: systems which scale in size in response to load. So this is a really important one to make sure that a potential cloud environment offers in order to make sure that it is actually cloud. Okay, let's move on to the final characteristic, and that's measured service. Now, the NIST document defines this as cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction appropriate to the type of service. And it says that resource usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the service. Now, my simplified version of this is that resource usage can be monitored, controlled, reported, and billed. Traditional and non-cloud infrastructure worked using CapEx. You paid for servers and hardware in advance. In the beginning, you had more capacity than you needed, so money was wasted. Your demand grew over time, and eventually you purchased more servers to cope with the demand. If you did that too slowly, you had performance issues or failures. With a true cloud environment, it offers on-demand billing. Your usage is monitored on a constant basis. You pay for that usage. This might be a certain amount per second, per minute, per hour, or per day usage of a certain service, for example, virtual machines. Or it could be a certain cost for every gigabyte you store on a storage service for a given month. You generally pay nothing in advance if it truly is a cloud platform. If you consume a virtual server for a month, but then for 30 minutes of that month you use 100 virtual servers, then you should pay a small amount for the month and a much larger amount just for that 30 minutes. Legacy vendors will generally want a fee to buy or lease a server. If this is the case, they aren't cloud, and they probably don't support some of the massively flexible architectures that cloud allows you to build. Now, before we finish up this lesson, I've just got an exam power-up. You'll notice these throughout the course. These are where I give you some key points which will be useful for the exam. So I want you to keep these 5 characteristics in mind as you go through the course. And every time I introduce a service, I want you to evaluate how that service matches with one of these 5 characteristics. I honestly believe that if you put in some time and make sure you remember and really understand these 5 points, it's going to help you massively in the exam and the real world. Now, you might be asking why. Well, it will help you shape how you design systems. It will help you with exam questions if you know if an answer makes sense or not. In most cases, you'll be preferencing answers which allow on-demand self-service, answers which allow systems to be accessible over any network and any access method. Your answers and solutions will generally be geared towards taking advantage of resource pooling. They should scale in real time using rapid elasticity and should always take advantage of AWS features to provide a low-cost measured service. So a solution which meets all of these 5 characteristics is a cloud platform. A solution which doesn't isn't cloud. And as you'll learn in the next lesson, there are different types of cloud, but they all share the fact that they meet these 5 essential characteristics. Now, thanks for listening. I promise you that this lesson will be useful. I try not to have too much abstract theory in the course, but there are situations, just like with this lesson, where some of the things will add a lot of value. This is one of those times, and I really want you to make sure that you understand all of these 5 essential characteristics. With that being said, that is everything I wanted to cover, so go ahead, complete this video, and when you're ready, I'll join you in the next.